question says the diagram shows a simple pendulum. Given that the period of the pendulum is 1.6 seconds, find the time the bulb takes to move from point A to point B. Okay. When solving this problem, we are going to use the formula for period, which is T is equals to T, small letter t over N. The capital letter T represents the period. N represents number of oscillation. An oscillation is one complete swing. When the bulb moves from point A to point C, okay, and then back to point A, that is what we call an oscillation. So when the bulb moves from point A to point C and back to point A, that is what we call an oscillation. So on the formula, N represents number of oscillation. T is the time taken for the oscillation, and that is what we are calculating here. So the question is also saying, find the time of the bulb takes to move from point A to point B. So they are only interested in the movement of the bulb from point A to point B. So since this is the formula we're going to use, we are going to substitute this data. Then we'll find the answer for what they are looking for. Okay. So the period is already given. Okay, let me write it down on top here. Period is equals to time over number of oscillation. So the period has already been given is 1.6. So the period is 1.6. We substitute our 1.6 seconds is equal to, time is what we are looking for. So I'll put X there because that is what we are looking for, over now this is the tricky part. We need to know what N is, the number of oscillation. We need to know what that is. Now from point A to point C and back to point A, that is one oscillation. It means from point A to point C, that is half. And it means from point A to point B, that is 1/4, which is 1/4. 1/4 is the same as 0.25. 0.25. So now we are cross multiplying to solve for X, which is the time. So X is equal to 1.6 times 0.25, which is going to give us 0.4. So the answer for question A is 0.4 seconds. Okay, meaning our answer is D. So question 1, the answer is D. Question 2, or the other question that was posted, says a person of weight 600 Newton at the bottom of a mountain climbs to the top. The gravitational field strength changes from 10 Newton per kg at the bottom to 9.97 Newton per kg at the top. His mass is unchanged as he climbs. What are his mass and weight at the top of the mountain? Okay, when we are calculating weight, we use the formula mass times acceleration due to gravity, which is the G there. So we're not given the mass, but we can calculate the mass from the information that we are given. So we are told the weight is 600 Newton. So the weight is 600 Newton is equal to, now we can solve for the mass using this information. So I'll put X where mass is, and we were told that at the bottom, the acceleration due to gravity was 10. Okay, so we can use this information to solve for the weight. So we simply divide by 10 to make X the subject of the formula, and on the other side, we also divide by 10. So X, which is our mass, is equal to 60, because when you divide 10 into 600, it will give us 60. Okay, that simply means C and D is disqualified. It is not 60.1, it is 60. So our possible answers is either A or B. So we must understand one thing. The mass at the bottom will be the same as the mass at the top of the mountain. Mass remains the same everywhere. Mass does not change. But weight changes. So weight at the top of the mountain is going to change. So the weight at the bottom was 600 Newton. But let's calculate what is going to be the weight at the top of the mountain. So weight is equals to mass times acceleration due to gravity. Okay, the mass we are saying will not change. The mass will remain 60 kg. You multiply 60 by, the question says the gravity at the top of the mountain changes to 9.98. So when you multiply 60 times 9.98, it gives us 5.598. Okay, so meaning our answer is A. The answer for question 2 is A.